Hi, Kaia. I'm hoping this explanation will help with some understanding of what they're asking you to do with these systems of linear equations. Also, I'm just using the problems that you had here, but if you want some more practice, I would be happy to make up some other problems for you that are similar. So, hopefully, it's okay that I'm just doing these problems. Okay, so the idea here when we're solving a system of linear equations, maybe the first thing I should talk about is what does that even mean? And what we're doing is we're looking for all pairs of variables, so like x and y together, that satisfy both of these equations. So, for example, like this isn't how we're going to solve this, but I just want to try to get at what I mean by that. So, if I'm looking at this first equation, I can see if x is 1 and if y is 5, I would say, well, that is a solution to the first equation. And I just kind of randomly picked one and then figured out the y that would go with it to get me to 11, right? So that's a solution to the first equation because 1 plus 10 is 11. That's fine. But 1, 5 is not a solution to the second equation. Because if I put 1 in for x, I would have negative 3 times 1. And if I put 5 in for y, I would have 5 there. And that is not the same as negative 5. Right? So I was just picking at, something that is a solution to the first one, but is not a solution to the second. So we would say that means 1, 5 is not a solution to the system. So that's just, again, trying to show what we mean by what is a solution and what is not a solution. And so the way we're going to solve a system like this, we have actually a few different methods, but probably the most common method is called the substitution method. And the thing you want to know about this is that it takes a few steps, and you really have to be organized about your work. So the substitution method for solving a system of linear equations. And the first thing you're going to do is pick either one of the two equations. It doesn't matter which one. So either equation for x or for y. That's going to be step 1. So let's see, over here I'm going to do step 1 for this particular system. I'm going to pick equation 1 and I'm going to solve for x. Since x is all by itself without a coefficient in equation 1, that seemed like an easy thing to solve for. If I was looking at equation 2, I would probably solve for y, since y doesn't have a coefficient other than 1, I should say. So if I was looking at equation 1, I would try to solve for x. If I was looking at equation 2, I would try to solve for y, just because that looks easiest, right? But it doesn't matter. You can choose either equation and solve for either variable. You get, your options are wide open there. All right, so there's my step one, solve equation one for x. And I like to write down what I'm doing so that I remember what I did later. So that would be, I'm going to subtract 2y from both sides. So if x equals 2y plus 11. So that's just another way of writing the relationship between all of the x's and y's that are solutions to equation one. Then step two is substitute the expression you got from equation one into the other equation. Or I should say substitute the expression from step one into the other equation. So since I solved for x in step one, I'm going to take this expression, the negative 2y plus 11, and I'm going to put that in for the x in equation two. I don't want to put it back into equation one because I already used equation one. So it's really important that it's the other equation. So my step two here, I'm subbing negative 2y plus 11 for the x in equation two. So that's going to look like negative 3, that stays there, and then I'm going to put parentheses around what I'm filling in for x. And then nothing else changes here, right? So the negative 3 stayed there, the y stays there, and the negative 5 stays there. But I just replaced the x with negative 2y plus 11. And then once we're done with those two steps, we're kind of done with the hard part. Now we're going to solve the equation from step two for the variable because now we're going to be always down to one variable. So solve the equation from step two. So my step three here, I just need to solve this equation, which means I'm going to distribute that negative 3. So 6y minus 33 plus y equals negative 5. And so I said solve equation from step 2. So there we go. And now I've got 7y minus 33 equals negative 5. Then I'm going to add 33 to both sides, so I'll have 7y equals 28, and then divide by 7. So y equals 28 over 7, so 4. Now I know what the y value is going to be, but remember, I don't want just a y, I need the x that goes with it. So I'm looking for an ordered pair. And I know the y is going to be 4, but I need to know the x. Right. And now once I have one of the variables, this y, I have all sorts of options. I can take that y value and put it into either of the original equations, or I can take that y value and put it in where I had solved in step 1. And that's usually going to be the easiest, but it's good to know that you have options. So you can, step 4, substitute the value from step 3 into either of the original equations or your equation from step 1. and then solve to get the second coordinate. So we're going to take this y, we know the y now, and we're going to either put it into one of the first equations or into the equation from step 1. That's going to automatically directly give me the x. So that's the one I'm going to do. So my step 4, I'm going to substitute y equals 4 into the equation from step 1. So that's going to look like x equals -2 times 4 plus 11. So that's, let's see, x equals -8 plus 11, so x equals 3. And so now I have my solution, this ordered pair 3, 4. And I always like to be able to check my answers. And so if I want to check, what I need to do is make sure that 3, 4 is a solution to both of the equations in my original system. So you'd go back up to the top and look at your system and say, okay, 3, 4. If I put the 3 in for x and the 4 in for y, does that solve the first equation? Sure, 3 plus 8 is 11. If I put the 3 in for this x and the 4 in for this y, I've got -9 plus 4 equals -5. Yep, that works. So I can see 3, 4 is definitely a solution to the system.